In this problem, we're going to deal with an example where we're changing the conditions and we're trying to identify an unknown. So we're going to go through the problem and we're actually going to break it down into two parts. So it gives us 60 grams of a solute is added to 100 grams of water at 50 degrees Celsius and dissolves completely. The solution is cooled to 30 degrees Celsius and some of the solute precipitates out of solution. So we're going to look at the first part to see which substances can be eliminated, and then we can figure out from the second part the other substances that can be eliminated, leaving it with just one option. So 60 grams of solute is added to 100 grams of water at 50 degrees Celsius and dissolves completely. The first thing I'm going to do is mark my 50 degrees Celsius and my 60 grams on my solubility chart and put a little dot there where those intersect just to help me keep track of what I'm looking at. Now I'm going to pick a substance that is above that dot in the curve so that I can figure out if a substance above that would be soluble or not. Notice when I talk about above and below, I'm only talking about at that temperature. So we're going to go above 60 grams at 50 degrees, and eventually we'll look at below 60 grams at 50 degrees. So let's pick KNO3. And what we notice is that at 50 degrees Celsius, KNO3 will dissolve about 90 grams of KNO3 in 100 grams of water. Since we only have 60 grams of our solute in 100 grams of water and it dissolves completely, that tells us that KNO3 is a possibility. It also tells us that anything else that is above that dot is also a possibility. So we can't eliminate anything yet, because the 90 grams is above the amount we actually have in our solution. Remember, the lines on the curve show us the maximum amount that will dissolve at that temperature. Now let's pick something that is below the dot, our green dot there, and still maintaining at 50 degrees Celsius. So we pick something below and we're going to look at KCl. And what I notice about KCl is that at 50 degrees Celsius, the maximum amount that will dissolve is 43 grams of KCl in 100 grams of water. So what I'm going to do is look at this and say, okay, I have 60 grams of solute. The max that will dissolve is 43 grams. So if this substance were KCl, it would not all dissolve. And that contradicts the information that's given in our description, because it says it dissolves completely. That means that we can eliminate KCl, but we can also eliminate any substance that is below the dot, because none of those have a high enough solubility to dissolve 60 grams at that temperature. So which ones can we eliminate? Well, that's going to be anything on the bottom, anything below the dot, because all of those have maximum solubilities that are less than 60 grams. Okay. So now what we're going to look at is we're going to mark out all the things that are below the 60 gram limit. We know now we're only dealing with the lines that are left, which are those that are above it. So the 4 KNO3, PbNO3, CaCl2, and NaNO3. Now we have to look at the new second set of conditions and determine which one best fits the description that's given, because it says it's cooled to 30 degrees Celsius and some of the solute precipitates out of solution. So we're at 30 degrees Celsius. We're still dealing with 60 grams of solute. That has not changed. There's still 60 grams of whatever this compound is in that container. And the green dot's a little bit harder to see. It's kind of right there between the N and the O in the PbNO3 formula. But that's our point we're looking at. And we're going to do the same thing that we did before. We're going to pick a substance above that point. But again, we're going to look at it at 30 degrees Celsius, because that's the temperature we're worried about. So let's look at PbNO3, 2. And what we see is that about 65 grams of PbNO3, 2 will dissolve in 100 grams of water at 30 degrees Celsius. So this tells us if we only had 60 grams of our solute, which is the condition given in the problem, that all 60 of it would dissolve. But this conflicts with what we see in our question because it says some of the solute precipitates, that means the solid comes out of solution, some of the solute precipitates out of solution. So it cannot be PbNO3 because if I had 60 grams of PbNO3 in 100 grams of water, it would all dissolve. Now, that means we can also eliminate anything else that's above it, so the CaCl2 and NaNO3. In this case, we only have one substance left. However, we're going to look and do a quick test just to make sure we're looking at it correctly. So we're going to pick something below, and we get KNO3. And when I look at KNO3, I see that at 30 degrees Celsius, only about 45 grams of KNO3 will dissolve in 100 grams of water. As a result, if I have 60 grams of KNO3 in there, it would not all dissolve. Some of the solid would come back out of solution because we change the conditions, the solubility changes, and the solution is going to adjust to that change. So when we were at 50 degrees, all 60 grams of the KNO3 would dissolve. When we cool it to 30 degrees, only 45 grams of the KNO3 will dissolve, so the remaining 15 will precipitate out of solution. And so as a result, what we're left with is that we're dealing this as KNO3.